All right, Intro to A&P. This is going to be a quick overview of muscle contraction, the sliding filament theory. Because of time, I want to just kind of have a nice clean break before we come back after winter break. I'm going to try to spread this out just a little bit. Just a little bit. All right. So this is the sliding filament theory. I'm going to give you a handout, but it's just kind of going to process how muscles contract. It can be very complicated. And again, I'm just going to try to hit the main points. You're going to get this image here at step 1, 2, 3, 4, 5, 6, and 7. I have a paper for you, but essentially what's happening is just showing you how the muscles, how the nerve sends the message to the muscle, causing the muscle contraction. So steps 1 and 2. So step 1, sorry, this is covered up. Basically, an action potential rise from a motor neuron. Action potential is a proper name for a nerve contraction. And then what that action potential will do, it'll cause the release of a neurotransmitter called acetylcholine. Acetylcholine is often abbreviated as ACH. So step 1, right, nerve gets there. Maybe I'm going to move this down here so you guys can see the steps. And then step 2, that action potential causes release of a neurotransmitter. And the neurotransmitter is essentially what causes, it's a message. I can't find a good place for my face anywhere, maybe over here. So step 3, ACH, which is the proper name for acetylcholine, will trigger an action potential in the sarcolemma membrane, which is, sarcolemma is just the outer membrane. That action potential, travels down the sarcolemma and the T-tubule to the muscle cells. So again, had this been a normal year, you would have had all these processes, but I'm just kind of showing you how it's like step 1, neuron, right, stimulates, releases acetylcholine. The acetylcholine will then trigger an action potential. So it's like a series of dominoes. And in step 4, that action potential triggers the sarcoplasmic reticulum, which is a thing that just stores calcium. So calcium is very important for muscle contraction. So what happens is once that action potential releases that triggers that sarcoplasmic reticulum, it's going to release that calcium, and that calcium is going to flood into a myofibril. And then what happens in step 5, the calcium allows for more formation of this term called a cross bridge. And what a cross bridge is, it's just a connection between myosin and actin. Those are two very important proteins. And this cross bridge causes the sarcomere to shorten or contract. When your muscles contract, they shorten. And so here's again just kind of showing, there's your sarcomere relaxed, there's your actin filament, which is that one that looks braided, myosin filament's in blue, you've got your Z line, kind of looks like a Z, and then down there on that actin filament, you've got the myosin head, which actually attaches. And so when things contract or get closer together, they overlap. And so what it actually looks like. So here's some details. Tropomyosin and troponin, which we're not going to get into, but these are proteins. They're found in very small quantities in the muscle, and they just help regulate a muscle contraction. And so basically what they do is they allow for the muscles to basically interact. So here's some detail. So the calcium binds to troponin. That troponin and calcium no longer binds the actin, so the actin's free. Tropomyosin is no longer blocking the myosin binding site, and the myosin binds the actin. So so if you look here, you've got the purple, that's your myosin, right? You've got the tropomyosin, troponin, there's your myosin head. The calcium goes in, and once the calcium goes in, right, calcium ion binds to it, but essentially what it does, it allows the myosin head to attach to a binding site of the myosin. So not the easiest concept, I know. And so it's just kind of showing you what happens when they move in. So then what happens, step 6, ATP phosphorylates or gives up a phosphate, the myosin, which breaks the cross bridge. So you form the cross bridge, and then ATP breaks it. And again, you'll have a handout for this. And then it just keeps repeating. So form a cross bridge, break a cross bridge, form a cross bridge, break a cross bridge. And every time you form a cross bridge, muscle contracts, you break the cross bridge, it goes back. So you form a cross bridge, goes to the center, and then goes back. So you got to think, remember, your muscles are getting shorter when they contract. Step 7, muscles relax as calcium is pumped back into the sarcoplasmic reticulum. And then that's pretty much it. There's some animations there, which I'll show you. And so as long as you can kind of get a general overview, again, I'm doing this kind of quickly for you. There are some animations here, which I'll probably show in class, but some of the diseases, right, these are what you're going to be doing for your case study. There's ALS, which is amyotrophic lateral sclerosis, or Lou Gehrig's disease. And basically what happens is that motor neuron degenerates, so you cannot send that acetylcholine. Myasthenia gravis, it's autoimmune. Antibodies attack acetylcholine receptors, so no signals received. So Stephen Hawking, who's a famous physicist, had this disorder. And then rigor mortis, why are dead people called stiffs? Because when an individual dies, they're no longer breathing, so there's no longer oxygen, so it's no longer aerobic. And so what happens is you have no respiration, you have no ATP. The ATP needs to break that myosin cross bridge, so those fibers stay in a contracted state. And so the fibers come together, the muscles get stiff, no ATP, they're going to stay there. And so rigor mortis, there's different types. There's rigor mortis, livor mortis. But in rigor mortis, the reason why the body becomes stiff is because there's no ATP to break that cross bridge. So again, that was quick. I would have loved to spend about 4 days on this, but you're going to get maybe a day of it. And like I said, the case study will be the assessment. So hopefully you got some of this. I'll have a picture for you. We'll go over it in class. We'll do all those things. So again, hope you find this helpful. It's me signing off from Me 102. Have a great day, and I'll see you sometime this